All right, so today we're going to talk about combinations. Okay, so we learned permutations is where order matters and it's picky, it's choosy. Like when you choose in first place, you have to choose first place and then you find your second place and then you find your third. Okay, combination is the arranging of things where order is not important. Example I use is pizza. If you call Pizza Inn or wherever and you're like, I want a pepperoni, mushroom, pepperoni, mushroom, banana pepper pizza. But then your friend calls behind you and he wants banana pepper, mushroom, pepperoni pizza. He said it differently, but you both are going to get the same pizza. So that is one combination no matter how you say it. Whereas if it was a permutation, those would each be a permutation. Okay? Also, putting in groups. If you put Bob, Sally, and Dan in a group, and then you're going to say, all right, well, Dan, Bob, and Sally are in a group. It's the same people. It's the same group no matter how you say it. Okay, so that's why a combination is chill. Order doesn't matter. There's a formula that goes with it, and it reads N choose R. And it's in your calculator also, but since we're doing virtual learning, Desmos is the place. And on Desmos, you would find it under functions, under statistics, and it's going to be your NCR. It's right there, whereas you had your NPR, your NCR is right there. And you would click it and you would do the same thing we did for permutations. All right, so the first example states a certain pizza parlor offers 20 different topping choices and is running a special on a large 3-topping pizza. How many pizza choices are possible? So your formula is NCR. Your N is your total of whatever, and your R is how much you're using of that total. Sometimes you'll use it all, sometimes you won't. So this is saying they're offering a total of 20 toppings, so it's going to be 20 choose, but they're running a special on getting 3 of those toppings out of 20. So it's going to be 20 choose 3. So we go over here, we type 20, 3, and it's 1140. So there is 1,140 different pizza combinations they could call in. Okay? All right, so we're going to do a couple more like that. That last part on the PowerPoint we're going to save for last because it's a different combination. Okay, and there's one up here, so we're going to go back to the PowerPoint in just a minute. So the next example is going to be 9 wild shoppers are rushing to grab one of the last 5 Elmo toys. How many different sets of shopper group could come away with a toy? So I'm going to show you about keywords with combination like I did permutation. Anytime you see the word set means a group, and that means it's a combination. Okay? So because if you think about it, it doesn't matter. Whoever's the first 5 in is going out with an Elmo. So if you're second, you're going out with an Elmo. If you're fifth, you're going out with an Elmo. So it doesn't matter if you're first and it doesn't matter if you're fifth, you're going out with an Elmo. Okay? So that means it's a combination. It's going to be 9 choose 5. We're going to go to Desmos. Desmos. 9 choose 5. It's going to be 126 different ways somebody could come out with an Elmo. Okay. Next one, 6 names we picked from a jar to be on a team. There are a total of 10 names in the jar. How many different combinations can be picked? Another keyword here is team. Team is a group, right? If I'm picking teams, no, you don't want to be picked last. But does it matter if you're picked last or first? You're still on that team. If I pick you second, you're still on that team. Okay? So it doesn't matter when you're picked, you still form that team. So it's a combination. So it tells you there's a total of 10 names, and you're choosing 6 to be up there. So this is 10 choose 6. And 10 choose 6. It's going to be 210 different ways. Alright, so the next one is a painter was carrying 8 pails of different colored paint and dropped 4 of them, making a big mess. How many combinations of colors could he have spilled? Now, just because it says combination does not mean that it's a combination. Okay, a permutation is a combination. It's just a picky combination. Okay, so this could be a permutation if it was talking about a lineup. So do not see that word and get lazy. All right. So you're carrying pills. You drop 4 of them. Does it matter? You dropped the red and the green. Did it matter what order you dropped the red and the green? No, you're still made a mess. You still dropped a red pill and you still dropped a green pill. So this is a combination. It does not matter. There really isn't a keyword here. So there was a total of 8 pills and you dropped 4. So it's 8, choose 4. So we go back to Desmos. 8, choose 4. So 70 different ways he could drop that paint. Okay. All right. So last one of the single combinations. Okay, and then I will show you what to do when you have 2 different types of combinations. All right. So it says a hockey team has how many hockey teams of 6 players can be formed from 14 players without regard to position played. Well, without regard to position played, that definitely means order doesn't matter. But you also have the keyword team here. So there's a total of 14 players and you're choosing 6. So 14, choose 6. So 14, choose 6. So 3,003 different ways you could choose your team. Okay. All right, so let's go back to the PowerPoint. Now, you notice in the combinations you were talking about a single thing and you were choosing from it. Okay. And remember when we were doing the fundamental counting principle, you just had different groups, but you weren't choosing anything out of those groups, right? So this is what happens when you have multiple groups and you're not choosing anything out of those groups. Okay, so right here it says there are 20 cats and 14 dogs at a pound. It wants to adopt 2 of each, so it wants 2 out of the 20 cats and it wants 2 out of the 14 dogs. How many possibilities are available? If it had said it wanted 4 animals, and did not care where the 4 animals came from, you would have combined the 20 and 14 and said 34, choose 4. But since it wants 2 out of the 20 cats, and when you're picking the cats, it doesn't matter what order, you pick cat 1 and cat 5, they're still going home with you no matter what order you choose them in, so it's a combination. So I have 20 cats, and I'm choosing 2 out of them. I want 2 cats, so that's why you have to keep them separate. And you have to do a dog one too. And so you have 14 dogs and you're choosing 2. So let's do that. That's 20, choose 2. Okay, and that's 190. And then we're doing 14, choose 2. Which is 91. Okay, so they're separate, but see how it says the word and? If you think back to 2 weeks ago, before spring break, and means to multiply. Okay, so we're going to multiply these 2 numbers. We're going to say 91 times 190. So my answer is going to be, that's your answer. Okay. So it's just, you just do 2 different combinations and you just multiply your answers. All right. So if we go back to this page, that last problem is the same thing. It says form a group. Well, group means a combination. Okay. So this is a combination. You can do these with permutations. Okay. You will on Friday, tomorrow's stuff. So this is a combination. It has 10 men, 12 women. It wants 5 men and wants 6 women. So it wants 5 of one, 6 of one. So you have to be particular and say 10. Whoops. 10. I have 10 men and I want 5 of them. I have 12 women and I want 6 of them. Okay. So 10, choose 5. It's 252. And then 10, 12, choose 6. Is 924. And then since they say the word and means to multiply, so we're going to say 252, times 924. So I'm using my calculator. You can use decimals. And I get my answer to be. And of course, it's going to be higher than your normal stuff because you're multiplying. And that's your answer. Alright guys, well that's it for today's video. Go on over to Canvas to find out what your assignment is for today. But if you have any questions, email me, let me know. I can do more problems if you need to, or we can just help you out, alright? Bye guys.